Hi students, how are you? In previous section, I explained about electron gain enthalpy and its variation in periodic table. Today, I am going to teach you about some irregularities or exception cases in the variation of electron gain enthalpy in periodic table. The first exceptional case related to fluorine and chlorine. Electron gain enthalpy of chlorine is more than that of fluorine. We know fluorine and chlorine belong to group 17. Bromine, iodine, acetatin are the other members of group 17. We know that in group from top to bottom, generally electron gain enthalpy will decrease. Let's see the values. Electron gain enthalpy of fluorine is minus 328 kilojoule per mole. Electron gain enthalpy of iodine is minus 295 kilojoule per mole. So from fluorine to iodine, value is decreasing. Electron gain enthalpy is decreasing. Okay, so previous class clearly explained from top to bottom electron gain enthalpy will decrease in a group. So here also like that, minus 328 is high value, minus 295 is less negative, and electron gain enthalpy is very low. Okay, that is iodine possesses very low electron gain enthalpy. This is about general trend. According to the general trend, what we can expect for fluorine and chlorine? We can expect low electron gain enthalpy for chlorine compared to fluorine. Why? Because chlorine comes below fluorine. We know top to bottom electron gain enthalpy will decrease. So normally chlorine we are expecting low electron gain enthalpy. But see here, minus 349. The value minus 349 is higher than fluorine electron gain enthalpy minus 328. Okay, electron gain enthalpy of chlorine is found to be greater than electron gain enthalpy of fluorine. So it is an irregularity found in the general trend. How to explain this? How we can explain this irregularity? We can explain this variation, this irregularity from the Bohr model of fluorine and chlorine. So let's draw the Bohr model of fluorine and chlorine. The Bohr model of fluorine consists of two shells, K shell then L. K shell contains 2 electrons, L shell contains 7 electrons. K shell is also represented like this, n equal to 1. N equal to 1 means first quantum level. N is equal to 2, second quantum level. Okay. There are 7 electrons are present in the L shell. When electrons added to fluorine, fluorine will change to F minus. During this process, energy will be released. So, electron gain enthalpy of this reaction is negative. The correct value is minus 328 kilojoule per mole. When this electron added to fluorine, what will happen? Electron will reach near to L shell, but from here this electron makes a repulsion with the electrons present in the L shell. Okay, the adding electron and existing electron in the L shell makes a repulsion. Both will make a repulsion. Due to this repulsion, addition of electron in fluorine is difficult. Due to the repulsion, addition of electron in fluorine become difficult. So due to the difficulty, only less amount of energy will release here. Okay. Now let's discuss about chlorine. Chlorine have three shells: K, L, M. K n equal to 1 quantum level, n equal to 2, n equal to 3. When electron added to chlorine, chlorine will change to Cl minus. Energy released during this reaction is called the electron gain enthalpy of chlorine. And what is that value? Electron gain enthalpy of chlorine is equal to minus 349 kilojoule per mole. And this value is found to be higher than electron gain enthalpy of fluorine. Why? Because in chlorine, addition of electron is easier. Addition of electron is easier, and one more thing, electron repulsion is less. Why electron repulsion less in the case of chlorine? Because in chlorine, 7 electrons are present in third shell, M shell, and M shell is generally larger than L shell. So due to the high size of M shell, the 7 electron can easily accommodate in that shell. Okay, so when an electron add, that electron can add to the M shell without repulsion. Okay, that is M shell, due to the large size of M shell, the 7 electron can properly arrange the shell. Space is more. So due to the space, the the repulsion between added electron and the existing electron is less. So addition of electron become easier. When the addition of electron easier, large amount of energy will be released. That is why the value is minus 349 kilojoule per mole. Clear? So the value become higher than fluorine. The next important property related to periodic table is electronegativity. The electronegativity can be easily understood from the example hydrochloric acid, HCl. We know HCl formed through covalent bond. H have 1 valence electron, chlorine 7 valence electrons. Both are unstable. For getting stability, hydrogen and chlorine share their electrons. Hydrogen attracts these electrons of chlorine, chlorine attracts the electrons of hydrogen, and both will get stability. And this type of bonding is called a covalent bond. So how many electrons shared here? 1 pair. So it forms single bond, HCl. Then out of these two elements, the element chlorine have a tendency to attract the shared pair of electron towards chlorine. Okay, I repeat, there are two shared electrons between chlorine, and both form a single bond. Okay, at the beginning it is at the center, both are located at the center position of hydrogen and chlorine, but later the atom chlorine have a tendency to attract the shared pair of electron towards chlorine. okay, and hydrogen push the electron to chlorine. The tendency of chlorine to attract the shared pair of electrons is generally called electronegativity. Okay, what is electronegativity? The tendency of an atom to attract shared pair of electrons in a compound is called electronegativity. Let's discuss the variation of electronegativity in periodic table. In periodic table, from left to right along a period, electronegativity increase. Can you tell the reason why electronegativity increase from left to right along a period? Because from left to right, atomic size will decrease, so the atom can easily attract the shared pair of electron, because shared pair of electron near to nucleus. From top to bottom in a group, electronegativity will decrease. What is the reason? The reason is from top to bottom atomic size is increasing. So due to high atomic size, the bottom element cannot attract shared pair of electrons towards it. So top to bottom electronegativity decrease. From left to right electronegativity increase. This is about the general variation of electronegativity.